Hello and welcome to week 3 of Statistics 2. For this week, we're going to become introduced here to what is called an analysis of variance, or ANOVA for short. And what an analysis of variance is that it's a statistical test that allows us to compare more than two sets of data at one time. Now, the last two chapters that we focused on in the text, we were running t-tests and various type of t-tests, but in either case, we were still comparing just two sets of data to see if one was significantly different than the other. Well, there's instances where you're going to have more than two sets of data. For example, you might have 5 columns worth of data and you want to compare all 5 of them. You have a couple options. One, you can take all the different sets of pairs that you can out of those 5, which would be a time-consuming task. Or you can run what's called an ANOVA, and it allows us to take a look at and make the judgment of, is there a significant difference of one of these sets of data compared to the others? And there may not be a significant difference, and then you would reject the null hypothesis, just like we have in the past, and move on. But this would allow us then, again, in one quick move, to identify that. Now, for this chapter, if you like, you can follow the steps that the textbook walks you through. Even if you want to use Excel, I still would hope that you read the text. This chapter is pretty deep in vocabulary and pretty deep also in the steps that it would take to run this by hand. Some of you like to run these by hand and you want to compare, for example, what you would do by hand with what we're going to do on Excel. But I want to walk you through how you can run this in Excel rather quickly. My other part of the plan for this week is this. I'm going to put together a screencast to walk you through, or walk us through, each of the items from the homework, except for 1613. But 1611 and 1612 are two items that I'd like you to do this week that try this week, and then on Saturday, I'm going to release a screencast that walks you through how to do those. Love for you to try it one time, and then you have something to compare it to. And then that way, if you catch any errors, you can fix it before you try 1613. So realize again on Saturday, I'll release that. What I'd like to do right now is, again, first show further down on the screen here. There's a couple screencasts that walk you through what a single factor ANOVA is. This is one, me walking you through with a sample set of data. And you can actually play along with it if you click on the Here button to get the Excel sheet as well. Down below, there are 2 videos that I grabbed off of YouTube. They're not me, much better than me, but I think this first one here it's a quick tutorial that gives you a general explanation of what ANOVAs are. It's a big picture type of method. And then this one here walks you through the actual math that's behind what we're going through in this chapter. So I encourage you to watch all the screencasts here. You can either read the book and then watch these, or watch these and read the book, however you feel is best for your learning. And again, I will follow up with a screencast walking you through these practice problems on Saturday. What I'd like to show you right now, though, is how to use Excel to run these tests so that if you don't want to take the time to plug through the samples that they have in the book, then you can use Excel here to walk you through it. Now, what I have here is a set of data from 16.11. And what you do is, up again to remember, under the data analysis, and then in the analysis tool pack, what we've been doing lately is working on t-tests. What we're now going to focus on is ANOVAs. And for this chapter, we're just dealing what's called a single factor ANOVA. So click on ANOVA single factor and hit OK. There's going to be one input range. It's important that you have your data all clumped together here, whether it's in columns or rows, doesn't matter, but you have it all adjacent to each other. So I'm going to highlight this whole section. These are grouped by columns. Each of these columns is a different factor. And then labels are in the front row. I highlighted the labels, so I'm going to click on labels. Our problem actually doesn't have a given level of significance, so I'm going to go with the default of 0.05. And then click in the output range and click in the box. And then I'm selecting a cell up here to have the output produced. And we have two pieces of information here. First, you get a set of data. This is basically some descriptive statistics for each of one of these columns. But then the key piece of information is down here. And this is what basically you want to do for 2 out of the 3 homework items. But read the text, watch the videos, and it'll explain what all of these mean and what we're going to be looking for in our decision process. So just like in the t-scores, we were comparing a critical t to our test statistic or t-score from our data, we're going to be comparing an F statistic or F value from our data and comparing it to a critical F. And the same premise of having a null hypothesis and an alternative hypothesis stands. And once we set it up, we're going to run the tests and we're going to compare, again, this F value to a critical F and determine whether or not we either reject or retain a null hypothesis. So good luck this week. And I will follow up again on Saturday with a screencast to walk you through these problems. Thank you.